Thiamine is a metabolite used in several biochemical pathways. A metabolite is defined as a substance formed in or that is necessary for metabolism. Thiamine is a water-soluble essential vitamin, also known as vitamin B1. It plays a critical role in energy metabolism, so it is needed for growth, development, and function in cells. Thiamine cannot be synthesized in our bodies, so it must be ingested. Sources of thiamine include grains, meat, and fish, while other foods can also be enriched with the vitamin. In the US, cereals and bread account for the major source of thiamine in our diets. Due to its importance, the general population has a recommended requirement for thiamine. This requirement changes with age. For example, children that are 2 to 5 years old require 1.27 milligrams, while men 20 years and older require 1.95 milligrams, and women 20 years or older require 1.39 milligrams. Thiamine plays several roles in the body. In the body, it is most commonly found as thiamine pyrophosphate, or TPP, and is used in the following reactions. It's used in the pentose phosphate pathway as an alternative route for the metabolism of glucose. It consists of two phases, which include an oxidative and non-oxidative phase. The oxidative phase synthesizes ribo-5-phosphate, a component of RNA, DNA, ATP, NADH, and FAD. The non-oxidative phase recycles ribulose 5-phosphate, the molecule synthesized right before ribose 5-phosphate, and turns it back into glucose 6-phosphate. The first step of the non-oxidative phase requires thiamine as a coenzyme to proceed properly. It is also used in the decarboxylation of pyruvate to form acetaldehyde. This is found in the ethanol fermentation pathway. The synthesis of acetyl-CoA in the citric acid cycle to synthesize ATP from glucose is also dependent on TPP. And finally, both the oxidation and synthesis of branched-chain amino acids are dependent on the TPP cofactor. As you can see, thiamine is clearly important. So what happens when we have a thiamine deficiency? First, it's important to note that thiamine deficiency doesn't only occur in individuals with an insufficient intake of vitamin B1. Deficiency of this metabolite can also occur through a lower absorption rate or higher excretion rate than normal, which is especially common in individuals with alcohol dependency and those infected with HIV and AIDS. At first, the deficiency can lead to weight loss and anorexia, confusion, and even short-term memory loss. The most common effect of thiamine deficiency is beriberi. This disorder is characterized by impairment of the nerves and heart. Nerves can be degenerated and lead to muscle atrophy and loss of reflexes, which is dry beriberi. In wet beriberi, there is an overabundance of fluid in the tissues, resulting in cardiac failure and poor circulation. Another disorder caused by thiamine deficiency is Wernicke-Korsakoff syndrome. This disorder is almost 10 times more common in people with chronic alcoholism. This disease is characterized by Wernicke encephalopathy, caused by lesions of the central nervous system, and without treatment can lead to death. Those that do survive develop Korsakoff psychosis, which is associated with severe short-term memory loss, disorientation, and the confusion between real and imagined memories. A mutation in the enzyme transketolase, the first enzyme in the non-oxidative phase of the pentose phosphate pathway, leads to a lower affinity for TPP. This mutation lowers the affinity for TPP to 1/10 that of the normal enzyme and makes an individual more sensitive to a thiamine deficiency, which can potentially lead to Wernicke-Korsakoff syndrome. In conclusion, as you can see, your mom wasn't wrong when she told you how important it was for you to get all the vitamins in your diet. So next time you're thinking about skipping out on your grains, meat, and fish, remember all the important mechanisms that require thiamine.